Today we're going to talk about thermoregulation. What is thermoregulation? Thermoregulation is a process that allows our body to maintain a safe internal temperature. Mechanism of thermoregulation can be divided into two, ectotherm and endotherm. Endotherms basically are warm-blooded animals like birds and mammals. They produce their heat mainly from their body's metabolism, and they produce the required heat to keep their body warm. For example, the muscle contraction is a way to produce the metabolic heat. Ectotherm basically are cold-blooded animals like the amphibians, fish, and reptiles. They produce less heat, so they have low metabolic rate. For example, they have good behavioral strategies for temperature regulation.
Many birds and mammals have countercurrent heat exchangers, circulatory adaptation that allow heat to be transferred from blood vessels containing warmer blood to those containing cooler blood. If environmental temperature falls, which is the surrounding is cold, birds raise their metabolic rate to prevent their internal temperature from falling as well. But if the environmental temperature increases, which is the surrounding is hot, birds must mobilize water to lose heat through evaporative cooling and avoid death from overheating. As we all know, birds have no sweat glands. Hence, heat must be lost through respiratory tract by panting.
In the leg of a wading bird, the artery that runs down the leg carries warm blood from the body. The artery is positioned right alongside a vein that carries cold blood up from the foot. The descending warm blood passes much of its heat to the ascending cold blood by conduction. This means that less heat will be lost in the foot due to the reduced temperature difference between the cold blood and the surroundings, and that the blood moving back into the body's core will be relatively warm, keeping the core from getting cold.
Mammal is an endothermic animal. They have high metabolic rate. Some mammals, especially hibernator and baby animal, have a lot of brown fat. This mechanism called as non-shivering thermogenesis, which is a way to produce heat production. For example, in a cold weather, a cat such as Persian, they have longer fur that provide extra insulation in order to maintain their body temperature. Meanwhile, in a hot weather, cat will lay on a cold surface to increase heat loss through conduction. They also reduce their physical activity and use less energy to prevent more heat production. In addition, some marine mammals, such as whale, they have thick layer of fat to regulate their body temperature.
Reptile is ectothermic animal, as known as cold-blooded animal. Their body temperature varies with the temperature of environment. They use behavioral method to prevent major changes in their body temperature. For example, lizard basking in the sun to increase their body temperature early in the morning. But when the lizard starting to feel burn of the tropical sun, it will move into shade or hiding under the rock. But for a big size of lizard like Komodo dragon, their mass of body are bigger, so they trap a lot of heat, as they can maintaining a fairly consistent body temperature, almost like a mammal.
Fever, also known as pyrexia, occurs in response to the elevation of an animal's thermoregulatory set point and most often accompanies infectious diseases. Fever is believed to be an evolutionary adaptation to fight off infection. Studies indicate that during infection, an increase in body temperature enhances leukocytes activity. This results in a decrease in animal morbidity and mortality from infection. The induction of fever begins with productions by many cell types of small polypeptides known as pyrogens. Pyrogens included interleukin-1, tumor necrosis factor, interleukin-6, interferon, and macrophage inflammatory protein. This occurs when infectious agents, toxins, or the lipopolysaccharides complexes in gram-negative bacteria invade the body. In addition, prostaglandins, products of arachidonic acid cascade that are produced by endothelial cells, are major participants in the pathogenesis of fever. When released into the blood, pyrogens reach a part of the hypothalamus called the organa vasculosum of the lamina terminalis, OVLT. This region of hypothalamus is highly vascularized, and the blood-brain barrier here is almost non-existent, so endogenous pyrogens and prostaglandin enter the brain easily from the bloodstream. Once in the hypothalamus, the endogenous pyrogens act on the endothelial cells to produce prostaglandin E2 and other arachidonic additional metabolites. These prostaglandin cause the set point to rise. Once the set point increases, the animal will initiate reaction to produce heat until the temperature rises to a new set point by shivering, vasoconstriction, and piloerection. Once the set point is reached, the animal maintains its new body temperature until the pyrogens are metabolized and production ceases. When this occurs, the set point decreases back to normal. The animal initiates heat-losing mechanism, for example, vasodilation, sweating, and counter-current exchange. Because the prostaglandin E2 is produced in the hypothalamus to increase the set point, non-steroidal anti-inflammatory drugs such as aspirin, flanaxin, ibuprofen are used to treat the fever. These antipyretic drugs block the enzyme cyclooxygenase, an integral enzyme in the arachidonic acid cascade, thus blocking the prostaglandin production.